Welcome back to Bissell Maple Farms YouTube channel. I am Nate. Here in my truck. We're about to do a road trip back to Vermont to take a tour of Glenn Goodrich's 2 operations. So we'll be able to look at the Eden Vermont operation, which I've never been to. I know Fred has. But yeah, it's evening, and Fred and I just got back from Rochester, New York, dropping off some syrup at a distribution warehouse there. And now we're going to head as far as we can drive on the energy we've got. So I'm leaving home here in Western Pennsylvania, heading north, picking up Fred, and then we're heading, hopefully, get up to about Watertown. So good morning. Fred and I woke up in Watertown. We made it there last night. Fred was a machine, I'd say about 4 or 5 years. 4 or 5 months ago, I called Fred and asked him if him and Cheryl were superhuman. Because I'm in my 40s, and sometimes I get up sore, and like my bones and stuff creak. And when Fred was helping me build Bissell Maple Farm, redoing the building, staying up late and blending, we did a lot of all-nighters, didn't we, Fred? Yep. I wondered if Fred was sore after those all-nighters. Were you sore after those all-nighters?
Yeah, sometimes.
You know what he never did? He never said anything. I think I whine more.
I just whined to my wife.
I would have been happy with, like, stopping 2 or 3 hours before we did. So we drove all the way to Rochester, back to Jefferson. So we left Jefferson, went to Rochester, back to Jefferson. I went back to Sharpsville. From Sharpsville back to Jefferson. Then we drove all the way to Watertown. So that was a long day.
It was a long day.
Do you know how much I drove? Zero, because Fred, something about he wants to live or something. He doesn't like it when I'm driving, like this. So it's a good deal for all of us. He gets to live, I get to work. So we are headed to Glenn Goodrich's. We're heading to the Eden location, and I'd say we're still about 2 hours? About 2 hours. About 2 hours out. At some point, we're going to have to stop and take a break. But yeah, it's beautiful up here with the foliage. I know we're past peak, but I hope you enjoy this and get to see all the beautiful leaves. I think the leaf pickers are out, and yeah, they'll be heading home here in about a week or so. All the leaves are gone. You've been here, eh? Cool.
Well, he's gonna have to unload this.
No, this is going to the other location.
Oh, okay.
So we're here at Goodrich's, and the sugar sifter is actually going to the Cabot location. So Glenn sells a lot of equipment to a lot of different farmers, and the farmer I'm selling it to asked that I take it to the Cabot location. So
There you go.
that's bees there, buddy. See them? Those bees, or are they? Those might be ladybugs.
Hi, I'm Glenn Goodrich. We have this maple farm at Eden, another sugar house back at Cabot, and we've been here for 8 years. First year we started with 38,000 taps, one evaporator, one RO, and now we're 140,000 taps with 2 evaporators, 4 ROs, and well, on a decent season we should make something like 75,000 gallons of syrup, and we have an excellent team of people that help us. They're great workers, great people, good thinkers, and I leave a lot in their charge during the season, because I can only be in 3 places at once, and there's usually about 8 places to be, so we have a good team. So a drop of sap coming from our furthest point is actually 5 miles or more away from here, probably 6. It would go down through a 5/16 tubing line and then hit a 1-inch main line and then into a subconductor that would be probably an inch over inch at the furthest point away, and then would enter a 2/2 into a 3/3 into a 4/3 before it hits the bottom of the hill, and then it would be pumped 1.5 miles from our main station over here, traveling in a pump line for 1.5 miles, rising 125 feet at the onset and then descending 200 feet over that distance, and then it would enter our main storage tanks here and direct into an RO. We have really tiny storage for the number of taps, about a 1/2 gallon of storage per tap. So
That's kind of against the rules. You're like breaking. Glenn, you like to break rules.
I'm pretty good at it. But I live here during the season.
I got you.
And if sap runs at night, I'm here. If it runs in the daytime, I'm here. And our crew, generally speaking, is here during daylight hours only, and we can get our boiling done then, we can get our leak checking done, and so the ROs will run sometimes 24/7 in order to keep up with the sap.
What is your favorite thing about maple syrup and the whole thing? Is it the same today as when you started?
Well, that's a great question. I love making it. It's kind of fun to sell it, and it's a whole lot of work, as everybody knows. Sometimes during the season, you almost get to the point where you wish you didn't have another drop to deal with that day, but you soon get over that and tap a few more trees for next year. But it can get kind of a grind after the 3rd night of no sleep, and that does happen here. We could do easier if we had more storage capacity, and we will have that someday, but just not today. We've put our investment into the woods, getting trees online, and getting the equipment in here to handle the sap, but we haven't invested heavily into storage capacity. But that does need to happen.
What advice would you give an upcoming sugar maker that you wish somebody would have told you?
Buy your maple syrup at the store. No, just be careful and watch your investment. Put your money in the best possible place. It'd be a lot of fun to sugar on an unlimited budget, but not many of us get a chance to do that. And so just watch your pennies and make sure you're getting a return on what you're investing in. and do the best job you can with every tree that you do. It doesn't matter how many. It's not about how many, it's about how good you do on each one. And our motto here is kind of borrowed from President Bush years ago. He had a motto of no child left behind in our schools, and our motto here is no tree left behind. So we try to be very thoughtful about each tree and make sure we're doing the best we can with each one, whether installing tubing, tapping, vacuum checking, whatever we're doing, we focus on each individual tree. Well, Fred, let's take a walk through the sugar house and we'll see some stuff.
Okay.
I like to start where the sap comes in. So
Before we start, are there any skeletons, you know, in the closet here somewhere?
we don't have a closet.
Oh, you don't have a
so
closet? Well, then we're good. We're
We
good.
might have a skeleton here
I didn't
and
want to
there.
see it, something, you know.
Yeah, everything is stored right out in the wide open spaces. So we're going through the evaporator room now, but I want to go to the tank area.
Already getting sap, huh, Glenn?
Yeah, we're getting some sap today. During the off season, I collect spring water. We've got a really good spring up on the mountain, and it's very low mineral content. So we use it to rinse the ROs during the summer. Membranes stay right in place year round. And then once a quarter, every 3 months, I'll do a soap wash on each machine. And these sap tanks were one of a kind. This is the first 10-foot wide sap tank ever made for the maple industry, and the 32 feet long, made by H2O Innovations out of Hamnord, Quebec. And it's kind of a good visual because when a tree's run pretty good, we can fill one of these tanks in an hour. And when it runs really good, we can fill a tank every 40 minutes. We can fill all of them in unison or one at a time, however it suits us for the day. They actually fill from the far end up through the bottom and then discharge from this end right into the ROs.
How many gallons does one of these tanks hold?
They're 13,000 gallons.
Okay.
So you use them all for sap, or do you have RO water that you?
So currently during 95% of the season, all of these are for sap. During the first part of the season, when we're experiencing really cold weather, we probably would put permeate in 1 or 2 of these tanks. We can put permeate, sap, or even concentrate into these tanks and still work with it. We've never had to put concentrate in, but there might be a day that we would.
So if you fell in there, how'd you get out, man?
Well, I guess you wait until the tank fills
Fills
up
up
and
and then you
swim to the
crawl
top.
out.
Yeah. There's usually a mermaid or 2 in each one of these tanks, and you might not want to get out.
Well, you know.
So have you ever had all these tanks full and just
Oh, yeah.
wondering if the ROs could keep up?
Oh yes, a good story about that. One night I was here all night. All the machines were concentrating as fast as they could go, and the boys came in the morning and saw these tanks. It's just hovering about a foot from the top. And then they go to the main pump station, and one tank, the main pump, primary pump, was pumping as fast as it could go, and the secondary pump wasn't on, and both tanks in the building were right up pretty full. And so the boys called back and said, "Do you want us to pump that second tank over?" And I said, "Well, I think it's doing good right where it is." I didn't have room for it right then, so we waited, and during the day the flow slowed down a bit, and then we were able to catch up. But you just kind of have to balance the equation and make room so that it all fits.
Flow rates is a big part of what we do, right? Like flow rates, it's not just storage,
Yes.
it's flow rates. Maple sugar, well, sugar maker / Chemical engineers.
Right, and mechanical engineers and civil engineers and
HR.
and thermodynamics. All of those sciences enter into what we do. And here we had to create a lot of the technology that we currently use. There wasn't any turnkey equipment to do what we need to do. H2O developed these tanks special for us, and now they're an offering in the catalog. This pipe right here.
Is this 4-inch?
This is 4-inch HDPE pipe, and it's fusion welded. We have the welding equipment to do that. And this is the size of the air lines going up into the woods on each of our, what we call superconductor networks. It's a 4-inch air line, a 3-inch liquid line, and it's pretty interesting when all those liquid lines run solid full. You better be ready on this end. It's coming in at that rate, probably in the neighborhood of 250, maybe even 300 gallons a minute.
So 4-inch, when you say fusion weld, this isn't something where you buy a barb fitting. You actually weld, you butt end and then weld them?
Yeah, so
you have a plastic welder then?
We do. It's simpler than what you might think. What it does is there's two collets that hold the pipe so that they line up with each other, and the collets can move in and out. So you lock them in, make sure they're aligned perfectly, and then open it up, put in a facer, which is basically a milling machine that mills the ends of the pipes. And so as that facer is running, you bring the two pipes together. It faces both ends and exposes new, fresh plastic and makes the ends perfectly aligned with each other. And then you open it up, take the facer out, put in the heat plate, and put it together on the heat plate. Outside air temperature has a big bearing on how long it takes, but something in the neighborhood for us, pretty close to a minute of time on the heat plate. When you see the plastic starting to roll just a little, you open that up, pull the heat plate out, and then push it together, and they actually fuse together. You're not adding filler metal like you would with an arc welder or another type of metal steel welder. You leave it locked together until it cools down to a certain temperature, and then you can unhitch your collets and advance the pipe ahead another stick and put another one in and repeat.
Wow. So how long does it take to do like one?
So we can fuse on a reasonable day pretty close to 1,000 feet of pipe, and they come in 50-foot sticks, and
it's pipe up here in Eden. It's like down in Texas. Like it's like oil refineries. It's not tubing.
Well, it all starts with this.
They run pipe.
And then we get smaller and smaller as we get further back into the woods. At the termination, then it's same as everybody uses. We've even got some 3/4 main line here. Most everybody wouldn't use that at all, but we have used some. And what we're putting in new is all 1-inch pipe. And I resisted that as long as I could, but it offers us some advantages. If we need to extend the main line at some point, we've usually got room to accommodate that. And with 3/4 pipe, you can max it out and not be able to add on to it.
So 4-inch pipe to 2-inch pipe, it's not just double the size.
Right.
It's right. What I think it almost 4. It's easy math to say 4 times the volume. I think it's 3.8, but
yeah, it's about 4 times the volume. Probably even as far as the amount of flow you can put through it is probably more than 4 times.
I got you.
For surface
friction
square inches, it might be 4 times, but the interior of a pipe flows the easiest with the least restriction. The liquid that touches the wall of the pipe is slowed down by the friction of the pipe. So the bigger the pipe, the less loss there is to the wall resistance.
I got you.
And so we calculate very, very exactly how much flow can come down a pipe, and that's relative to its diameter and its slope. An airline slope doesn't amount to much, but a liquid line can aid its conductivity immensely by being steeper. But you can only make it as steep as the ground allows you to go. So,
Do you use spin seals up there?
we do on our mainline entries. Those are pretty new for us. For the longest time we used H2O saddles. We had very good results with those. The best results of any saddles that we've tried. And but then we had to get on the wagon and try the spin seals, and we like those pretty good. We haven't had any major kerfuffles with it, but you have to be careful. That's something you have to put just your best guy on and not cycle in and out guys. Once you learn what to look for, then you can be very successful with them. But a new guy, there's a learning curve.
That's very optics too, right?
Yes.
The beads of plastic
And just going in and out of a shaded area or a sunny area while you're doing it.
that temperature change can affect it.
Yeah,
Huh.
drastically.
But the likelihood of a leak is far less.
Right, if they're done right.
I got you.
Yeah. Yeah.
So I've washed a lot of tanks. I know he washed one time.
Is that right?
But
Captain Guard knows right here.
how do you do it in here?
So I have a tank ladder.
There
right
it is.
here.
Oh, okay. So you crawl down there.
Yeah. Oh yeah.
Oh, I got you.
The tank ladder hooks right on.
Huh.
And then I go down in with my tank brush, just a soft bristle push broom, and a garden hose. We have a hose reel at the far end of each tank.
That's the job I like, right? Captain Garden Hose.
Yes, and go down in and spray down the tank, brush it, and then spray it down again. And these tanks are kind of interesting. If you can get a shot of the end wall down there, you'll see that the tanks slope from the back end to the front end 4 inches. We're an inch every 8 feet of slope on the floor under the tank.
So you get it all.
Yeah, and washing becomes easy and draining the tanks becomes easy. We lose 4 inches of capacity, but I've never had to have that 4 inches. But I wash these tanks every day, so
Yeah.
it's nice to have them so they drain.
So you
really
can
well.
see it on that back wall.
Yeah.
It just goes from,
Yeah,
a small, you can't tell up close that they're actually sloped.
right.
But if you look at that back wall, you'll see that it's actually, you said how much? 4 inches of slope?
4 inches of slope in 32 feet.
So you can see it from the back to here.
Yeah, and we poured the concrete that way under the tanks, so we didn't shim anything. Really good job with the concrete so that the tanks have an even base to set on.
So the slope is in the concrete or in the fabrication?
In the concrete.
I got you.
Yeah, and then we didn't have to worry about any of that. Just getting these tanks in here was kind of a project.
I was thinking about that when I
Yeah.
saw it.
We didn't have the ROs in at the time, and we pushed all the tanks to one end and was just able to get the last tank parallel parked in here. And then we spaced them, put the catwalks between, and originally my plan was to have 6 8-foot wide tanks. And the day I went to Ham Nord, Rock was just wheeling a 10-foot wide tank out of the shop, and I said, "Can you make a 10-foot wide tank?" He said, "Yeah, I think we can." And so they did, and so we gained a little storage, and I have one less tank to wash every day. So that's a big help.
It's using your head, Glenn.
Well, I try it once in a while,
Yeah.
So this is about 65,000 gallons of sap storage,
right?
130,000 taps.
140 this year.
So you're less than a half gallon.
Less than a half gallon. Oh, in
Spray
theory,
rules.
we have some tankage at the main station
I gotcha.
that we can see a little bit later.
I got you. So there's 1, 2, 3, 4, 5, 13,000 gallon tanks. Probably 13 a little change. Were they right there?
I don't even know. We call it 13.
So 65,000. I like having a gallon plus.
I know.
I don't want to work that hard. He's on. This is
Okay,
awesome.
we'll go down to the RO department.
The RO department. When you bought these, did they come with a guy?
So these are specially built machines. I told H2O, Rock at H2O, that I wanted a machine that could handle 6,000 gallons of sap an hour. I'd done my math, and we figure 0.18 gallons of sap per tap per hour, and that's been pretty accurate. In a smaller woods, you'd probably want to figure more than that because they could all open up at one time. Here, we're spread over so much acreage and elevation difference that the low ones start first, the high ones generally start last, and so it doesn't all hit at the same time.
So there's two things. Not everybody in the Maple Belt is at the same level. And when they'll watch this, it's in Vermont, it's kind of normal. You guys talk about elevation, and I've heard terms like I don't know the words you guys use, but it like freezes maybe down below, but not at the top, so the sap will start running.
Yes.
And you're dealing with elevations, and in the Midwest, the elevation really isn't a key part of what we're dealing with. So you'll have different areas of your sugar bush running at different times.
Exactly.
And when you say 6,000 gallons an hour, do you mean 6,000 gallons of sap turned into the concentrate that you want to boil? Mm-hmm. So it's not just, okay, I'm processing 6,000 gallons of sap from 2% to 4%. You're processing 6,000 gallons of sap from 2% to a
30.
much higher 30. Okay. Yeah. That's a big difference because you hear a lot of RO talk, and I want to just make sure that the people watching understand that you're not just saying, hey, I pulled 6,000 gallons of water out.
Yeah.
No, you pulled 6,000 gallons of water, but you actually made 30 bricks. Is that right? Mm-hmm. Holy cow. I had no idea.
One pass?
One pass.
Jeez. What's the density? Like 30 bricks, if water weighs 8.3 pounds and maple syrup weighs 11 pounds, 30 bricks is about the middle. Does it weigh about 9.5 pounds?
Don't even know.
The concentrate has to be heavier, right?
Yeah, it's a bit heavier. Probably not as much as you'd think, but we can take 1.5 sap here and turn it into 30 bricks in one pass with no trouble at all. The pipes that feed the RO are 3-inch pipes.
Okay.
And something really interesting to me, the pipes that take the concentrate away are these 1/8-inch ID pipes up here.
Wow.
And there is 3 of them on the machine, but they're taking 6,000 gallons of sap an hour in, and all the concentrate's going through that 1/8-inch ID pipe. So if you get where you can see this.
Little heat exchanger here?
Yeah.
Yeah, this is a little plate and frame heat exchanger.
Yeah, exactly.
But what do they call these? These aren't gasketed. They're not soldered. It's there's a term
They
for it.
really are soldered.
Are they?
Yeah.
This little heat exchanger, what's this for?
Okay, this heat exchanger cools the concentrate down with just surface water. So when it's coming out of the machine, maybe it's 50 degrees. If we rely on the refrigerated bulk tank to do all the cooling, and we've got multiple machines going, it can't keep up. So
So the concentrating portion of making concentrate, there's going to be temperature increases from the pumps and impellers. That's how we get our heat oftentimes when we're washing.
Yeah.
So you want to cool it down as fast as possible with this.
Yeah.
Is this that like mountain spring water?
Yes. So we use surface water. sometimes spring water, but most always it's non-spring water going through this side of the exchanger, and then the concentrate is going through this side. And we always feed a heat exchanger from the bottom up so it stays full all the time. And we plumb this in so that when we wash the RO, we're also washing the exchanger.
I got you.
And that's pretty critical.
Braised.
Braised, yeah.
This is braised. We drove by this yesterday, Fred.
Did you?
Yeah, twice.
Yeah.
We drove by it, well, yeah, 4 times. No, 3.
Oh, yeah.
We drove
Buffalo.
out. We drove out past it. I saw the Xylan brand. We saw the Xylan building.
Uh-huh.
So we drove out to Rochester, back, and then again. So we drove by that building 3 times.
3 times. And there'll be one more tomorrow.
Oh, yeah, one more on the way back.
So this will take it right down to like 38 degrees.
Wow.
And at Cabot, that's all we do for cooling our concentrate. 38 degrees on the exchanger and then into the concentrate tank.
So this is pre-cooling before it even goes into the refrigerated bulk tank.
Right.
And pre-cooling is kind of like how we used to use preheating with steam for sap.
Exactly.
You already make the energy. You've got it here for free with the mountain water.
Mm-hmm. And so this saves us a lot of electrical energy to cool the concentrate. It gets it cold quicker.
Do you have a differential, like you can see the temperature going in and the temperature going out then?
To be honest, I don't have that capability. All you need to do is come and put your hand on the pipe going in and the
Yep,
pipe going
that's
out.
cool.
You can see the difference, but to put a number on it, it really doesn't matter. You're doing all you can do, and you hope you're doing the best you can do.
Gotcha.
But it's taking it from 50, sometimes even 60 degrees, down to 38 to 40 degrees.
That's nice.
And huge help on the refrigeration. There's 4 RO machines here, and it's rare that all 4 would be concentrating sap at the same time. There'd always be one in a wash mode. So 3 machines going on that bulk tank, it can't cool fast enough.
I gotcha.
I didn't know how that would play out. That tank was built to handle 95 degree milk temperature going in and cooling it right away. But apparently we're making concentrate faster than the cows could make the milk. So anyway, it gives us a leg up on getting it cooled down.
Very cool. So you got a little sample spot here to check.
Yes. This sample spot is really critical so that we don't make a boo-boo. If I misoriented a valve and sent concentrate right down the drain, I could see it here.
Oh, it's heartbreaking.
It's hard to lose sap, but you don't want to lose concentrate. So we've got a lot of valves here, every RO does, and you want to make sure that everything's oriented the right way. And this is just a visual check so you can see. This machine was my first machine. And so in year 1, it concentrated everything. Year 2, I put this one in, so they were doing half and half. This machine is always the first machine I start. And if we get into difficult sap, that's always my primary machine. I want to use up these membranes first and save my newer machines. So this machine has finished its 8th season, and they're still original membranes.
Wow. So that means the cleaning process is good.
Still doing very close to 6,000 gallons of sap an hour coming in. And you might as well say 6,000 gallons of permeate going out.
Wow.
And about, depending on sugar content of sap, about 5 gallons a minute of concentrate going to the tank. At 1.5 sap, it's taking 60 gallons of sap to make a gallon of maple syrup. And by the time this RO gets done with it, we're using 3 gallons to make one.
Gotcha.
And so our fuel savings is immense. There are times in our season when we're getting a lot of manganese and iron oxide, where we're backing off the concentration some because our membranes just get plugged up with mineral very
Gotcha.
quick. And so during that part of the season, we have to do citric acid wash several times a day.
That's probably the most frustrating time of the year for you.
Boy, it is. It is. Yeah.
When the minerals build up in membranes, and I hear this all across the Maple Belt. A lot of people don't have it, and
Yep.
some people, their soil, they're blessed with
Yep.
a lot of mineral.
Back at Cabot, we never citric acid wash. And that machine has been in place for 15 years and still original membranes in it. It only goes, well, we only take it to 18% because we have the LaPierre Turbo piggyback there. So by the time the flue pan gets it, we're probably in the 25 brix range, and that's a happy place for that machine to run.
Very cool. Where is your concentrate tank?
That's way out yonder.
Is this your concentrate?
This one.
Wow.
So this concentrate tank is a 6,000 gallon dairy bulk tank and refrigerated. When I bought it, I thought it was bigger than I needed, but then all of a sudden it got too small. And what makes it too small isn't that we need a lot of storage here, except when sap runs hard all night and machines are going all night. This will get full by 3 o'clock in the morning. And so I had this tank specially built. It's 3 feet wide, 16 feet long, and 7 feet tall. It's about a 1,300 gallon tank. So when I run out of capacity here, I can just open a valve and have concentrate fill from the bottom of this tank, where it's already cold, right up into this tank.
Just seek its own level.
Seek its own level, that's right, and keep concentrating. And then by the time the crew gets here, we'll boil this one out first, and it'll be nice and cold. You wouldn't want to let it set out for a long time. This one stays cold. This one will warm up as time goes on.
That lets you start first shift at 7 o'clock instead of 3 o'clock.
Right.
Gotcha.
Right. Yeah.
So do you have the compressor running, or it's just, okay.
There's 3 compressors on this tank. And what made this tank very attractive to us was it was a 3-phase tank. And we have 3-phase power here. And nobody else in the world could use such a tank. So it was priced sort of reasonable. Didn't seem reasonable at the time, but
What temp do you keep your concentrate?
35.
35.
35 Fahrenheit is the temperature that this was set to operate at. It's what it was intended to operate at. I asked the technician if we could drop
Make it
it down
slushy?
a few degrees, but he said he didn't advise it, and we found that we don't need to.
There's no real biological activity happening that cold.
At 35 degrees, none. The first year that we transitioned from flat pans to steam pans, we didn't have a steam pan ready to go when we started tapping. And on Christmas Day that year, we got a shot of sap come down the pipe. So we concentrated it, put it in the chill tank, brought it down to 35 degrees, turned the compressors off so the agitators didn't continue to come on. And about every 4 days, I'd restart the compressors, cool it back down again. And we kept it in the tank for 6 weeks and then boiled it, and it made table grade syrup.
Wow.
After 6 weeks of storage at 30 brix. So that was a shock to me that it could last that long.
So I got to ask this high-tech question.
Okay.
Why is that C-clamp on that?
I saw it and I said, boy, if that drops down, and then I see they've reinforced. They got extra.
Yeah.
They're not going to let that C-clamp do everything. That baby right
Well,
there.
don't you have to
That
let
would
the
be
air out, though,
catastrophic.
in order to get
Yeah.
your level? Or?
So that's a buffer. When you first start to let concentrate in here, there's a little restriction to flow in the elbows, and so it'll just burp bubbles up and make a mess.
Make a mess.
So by putting a little restrictor valve on there, it still allows it to vent,
I see.
but it doesn't.
That's your governor then.
Yeah, that's the governor.
I got you. That's awesome.
Well, I knew it was high tech. I just
It's high tech.
It's beyond me.
Yeah. Well, that's a.
I can't wait to tell some of my Glenn stories when I got to listen to you speak. It's going to be good because you've got some good things that just stuck in my brain that I've gone and repeated. I hope they're still accurate.
Yeah, probably never were. Yeah.
Oh, you know Fred.
We're just keeping going.
Never were.
So while we're back here, you can see the steam manifolds
Wow.
that come in. These two header pipes are 3-inch steam pipes, and then the steam goes into the 1-inch pipes and down into the pan. The condensate comes out down here through the steam traps and out through and back to the boiler. The concentrate is actually pumped into the pans. We have 2 NPO pumps that are open impeller pumps that won't build a lot of pressure. If sap can't move through them, they just sit there and spin. A closed impeller pump would put more pressure and wouldn't be as desirable here. So open impeller works good, and we keep those spinning all the time, and then the valves open and close as we need straight into the pan.
So the conventional is you have head pressure from a concentrate tank
Right.
feeding a float, and
Yeah.
you basically have a pump that's always keeping positive pressure.
Yes.
And then that valve will open and let your sap in when you need
Exactly.
it. I got you.
Yeah. So when this tank is full, it would almost feed in if you could get it primed. But then when it gets empty, you need a bit more push on it to get through. And so these work out really well. To try to put a concentrate tank up in the rafters of the building here just wasn't going to work. And it doesn't work that well in most sugar houses because that's the hottest place you've got.
Good point.
And so even back at Cabot, now for 15 years, we've been pumping our concentrate into the evaporator.
Keeping the concentrate cool.
Yeah.
You know, every other farmer's got well, we can't shut down because our concentrate's up there and it's going to get hot.
Right.
And that means the quality at the beginning of that concentrate tank is not the same as the quality at the end either.
Yeah, exactly.
Whereas this is going to be very consistent.
Yeah. And we can shut down. If we get to 5 o'clock in the afternoon and the crew has to go home and we're not pressed that hard, we can leave concentrate overnight if need be. Some nights you just can't because you're going to run out of space.
I got you.
But we can start and stop as needed. So it allows us more flexibility to choose our boiling schedule instead of the weather and trees determining our boiling schedule.
Back to the evaporators.
Okay.
These are steam fed. You had the, what do you call them in the back? The headers.
Yeah.
And going to steam. Game changer.
Oh, it was. It was a hard call for me. We originally designed this facility so we could handle 4 of our 7x20 flat pan evaporators. And when I first started with them, I was confident that each one could handle 50,000 taps, but end result was they couldn't. They were going to be comfortable with 35,000 taps each, but that wasn't going to get us where we needed to be.
What is the bottleneck, or what causes the need to have?
Just the mineral buildup.
I got you.
It's a heavier mineral area than Cabot where we normally operate. So after we were into it a couple of years, we knew that we had to do something different. We're facing putting in the 3rd flat pan evaporator, and so started talking with Clayton at MES, Clayton Christie, and we decided to take the plunge, and so we put in one steam pan, the boiler, and piping to get in here, knowing that we were going to have a second pan in the second season, which it was season 4 for us. Excuse me, season 5. And we did put the second pan in for the next year, and the 4th RO went in at the same time. Both are supposed to be installed before the season started, but as usual, you don't do it that way. So we're installing and boiling at the same time, and we got it done. Farmers always do, and good thing we did, because after that we had just a ferocious run of sap that put us right into overdrive.
Nothing gets projects done faster that we put off or forget than sap running.
Right.
All of a sudden we become superhuman.
Yes. So,
It's funny.
long story short, not very complicated here. Each of these machines draws into the tank that you see in the front, and once we standardize the density, we turn on a pump that will send the syrup up and overhead into this bottom tank here, and that's where the filter aid is added. This device
See the
over
mixer.
here, yeah, this device is the filter aid adder.
What? There's such a thing?
Oh yeah, this
A
was
filter aid adder.
we.
That's cool. Is it just kind of screw vibrate it?
Just an auger in the bottom, pretty simple, but it's a variable speed motor, so we can turn it up or down, whatever we
I
need.
see that. That's a good idea.
And the agitator is also variable speed, so we can make it operate at the right amount of stirrage. And we add filter aid in the hatch cover in the top, and this is something H2O helped us to create.
It's a good idea.
It wasn't what I wanted. I wanted to be able to inject filter aid direct into the suction line of the filter press. But adding a dry powder into a hose that's putting hot syrup, sticky, wet syrup into a filter press pump seemed to be a tough nut to crack.
Need something called an eductor.
Yes. Yeah.
Eductors are different than venturis. Venturis are for air.
Yeah.
Eductors are for liquid. Doesn't take much flow through an eductor
Yeah.
to get a lot of agitation in a liquid.
So maybe someday we'll have that, but for now, this is what we have, and it works very nicely for us. So again, we have an opportunity in this tank to check density again if we need to. Then the filter presses pull it out of this tank, and after the filter press goes up into the upper tank here. And let's have a look at the filter presses and talk about how all that functions. When everything's tuned up nicely, we can make as much as 800 gallons of syrup an hour. And I won't fib to you and tell you it's always that speed, but that's what it can be. If the ROs are tuned up just right and the pans are clean, it can come out at 800 gallons an hour. So at the start of each day, one filter press can handle that kind of volume until it starts to get dirty, and then it slows down to the point that it can't handle that volume. We'll start up a second one and keep the first one going, and then the second one eventually gets burdened down, so we start a third one. The first one's still going. Before we have to start the fourth one, we'll shut down the first one and clean it, make it ready to go again. By then the fourth one is headed, and we need to be able to start back on the first one again.
I got you.
In most days, we can operate on 4 presses and not have to change anything on the fly. But on a big day, we would be changing several along the way.
Those are good days.
Those are good days.
High class problems.
Yep.
How does your wife pull them out of there when they're full of DE and everything?
My wife doesn't spend much time here because she's managing the operation at Cabot, and she does a super job there. But she'd love to be up here some, not all the time, but some. But her schedule just doesn't allow it, and so we have guys that can pick these out, and then we have guys that 2 of them can pick them out. So they are heavy. They weigh a lot, but these H2O plates are much easier than any other press in the business, in that when you lift them out, you only have to lift that high and they can come out.
That is nice.
The frame is cantilevered down so that it's much lower than any other press in the business.
I noticed that.
And we like that feature. We've gotten plates made. We have some thin cavity plates that are 1 3/4 wide, and then we have thick cavity plates that are 3.5 inches wide, and then our D&G press, that one functions really well too. It's harder to change, but it'll put a lot of syrup through.
You want to make sure you ate a good breakfast.
Yeah, I know it.
So I can see, you said these are 1.5
inches.
and you can see these.
Yeah, we've
You've got them
bolted 2
both,
1.5 ones together. So
You've got
that
3 inchers.
they function as a 3-inch.
I got you.
Well, the disadvantage is you're buying a lot more paper here.
Yeah, with the 1.5 ones. But when it's really tough to filter niter beginning and end of season,
You'd rather have
thin
this.
plates work better. When it's really a lot of white niter, coarse sand, then the thick ones work better.
Very cool. Good idea.
Yeah. And each press can operate on its own. They were manifolded together, so you're just changing valves activates whichever press you need. And we put needle valves on so you can really tune them in so they run at the speed you want them to run.
That's a good
at.
idea.
And
These are a needle valve that are basically variable.
Yeah.
Move it where you want.
Yeah.
You can have it barely going, or
Yeah. And with that, we can.
Ball valves just aren't. You know, you play with it a few times to get it there, but that you can really dial it in, literally.
Yeah, exactly. And just keep a press going. We never shut a press off after it started. Never. It just keeps going nonstop. When you shut one off, my theory is that this cavity is full of syrup and filter aid and niter, and it's shooting through these holes to come up into this cavity. And when you stop a press, all that sediment, that particulate is going to sediment out and drop down in the bottom. When you take the press apart, you see heavy layer down here and not much up here.
Mm-hmm.
So by keeping it going all the time, you're better able to keep that in suspension so that you get even layer on the entire press.
Somebody asked me how these things work. You know what I tell them?
Good.
I have no idea, and no one does either. You just make them work somehow with a little feel. Hold your tongue just right.
Yeah.
It's like an art and a science.
Yeah.
So, how does this work? I don't know. I just make it work.
Well.
Don't ask me. We don't really know what's going on here. It's funny.
We kind of do.
Yeah.
But, yeah. Let's see, what else? So as I said, the filter aid adder can adjust the volume of filter aid that goes in depending on what the day of syrup is.
And then the packaging.
Yeah.
What do you like to use?
Well, first we like to use clean barrels. This is a barrel washer. A barrel goes on this spray ball, upside down. The bung goes on over the spray ball, and then you open this valve, which sprays really hot permeate into the barrel. We're heating permeate with the returning condensate / steam that's headed back to the boiler.
Gotcha.
And so we have a pretty unlimited supply of hot water. And so we have both a hose here and a barrel washer, so we can wash the inside and the outside of each barrel before we fill
How much water do you think you would use per drum to clean it?
Probably not more than 5 or 6 gallons. But
That drum gets hot too.
it's
doesn't it?
hot. And that's how we know when it's done. If you can't touch your hand on it and stay there, it's probably in good shape. And of course we wash our barrels when we empty them. We wash them again before we fill them. And we get good results. And by the way, my nephew Chris Goodrich builds these for us.
Yeah, this is a good idea. I've been wanting to look at something like this myself. I've seen copies.
Yeah.
It's a pretty good idea.
Yeah, to put a barrel on it can be pretty easy. I don't have a barrel.
Because you can roll it right over. And
You kind of can. You stand it on its end, and the bung headed toward this, just tip it back and roll it around, watch it drop on, and just tip it down and swing it around onto the incline. It inclines just enough so it drains nicely. And
You can get 40s in, 55s in.
yeah, good. This one interchanges on this hose, and this becomes a spray ball for our totes.
I see that.
We're filling lots of 350-gallon totes.
What are the guys? What would they rather fill? Drums or totes?
We fill a 55-gallon barrel every 5 minutes, so that's busy. Poor barrel guy, by the time he washes a barrel, gets it in the filler and fills it, and we're filling 2 at the same time. Then you take it off the filling line, screw the plug in it, and
There's no like coffee break over here. You're moving.
you're moving. And then you weigh every barrel, put a tag on with the weight, the date of production, and the sequence number. So the first barrel that we fill on day 1 of the season is barrel 1, and then the last barrel of the season is barrel, hopefully 2,000.
Million.
But then you know the sequence of every barrel that was filled.
That's helpful.
Yeah.
Especially
So-
to the packer, actually.
It is, yeah. If you're emptying barrel number 500 and 501, they're going to be the same thing.
Mm-hmm.
Yeah.
Almost always.
Almost always.
Yeah.
Yeah.
Very cool.
So most of our barrels are 55s. We can sell 55s to almost any buyer. We do fill some 40s. We have lots of small maple producers that struggle to make enough golden syrup for their market, and so they buy golden from us in 40s, and they don't want to deal with 55s. Most sugar houses aren't very conducive to wrestling a 700-pound barrel.
Most people
Yeah,
aren't
that
very
too.
conducive.
That
Yeah,
too.
you gotta horse them things. The boys up in Wisconsin are built for it, I gotta say.
Yeah.
So does your golden, is it good for sugar?
We can make sugar out of it. It's really best suited for maple cream, maple candies, and just plain golden syrup. But a lot of our buyers are using it to make candy and cream out of.
So what grade do you prefer? What color do you prefer?
For
Eaten.
eating, oh, well, there's no question.
Yes.
Vermont Golden is the one. That's what we have in our refrigerator all the time. If I'm going to do some serious cooking, then I'd do something darker. But
Yeah.
for just general, straight up, I think we use it on waffles, but I can't remember. We don't get there very often. But good thing, I'd weigh 1,000 pounds if I ate like I thought I ought to.
Yeah.
Yeah, come on over this way. Well, we've got a kind of an octopus going, but we like to change our hoses regularly, but these hoses have been on here for a couple of years and they get nited up. But this tank, again, something that H2O built special for us. There's basically a bulk tank agitator in it to stir and homogenize the syrup that's in the tank. And then there's a little tiny pump here that's pulling out of this plumbing circuit and putting it back to the top. And what that does for us is it tells us the temperature of the homogenized batch. And so especially the first round of the day, we'll do a really exact check here to make sure our densities are accurate. And the way that works is we can draw, once we get it stirring, good shape, and we're filled up 2/3 full, I can draw a sample up in this vial and float my hydrometer right in the vial.
Oh, wow.
That's cool.
Yeah, I trust hydrometers.
Me too.
I don't trust refractometers.
It's a lot of
Yeah.
human error on those.
Yeah, so I can float my hydrometer in there. I know what the temperature is. I know how to correct for temperature. And then I get an exact measurement on the entire batch. And if it's consistent with what the evaporators are doing, we're good. Then we'll continue through the day. We don't check continually because we're constantly pulling out and constantly putting into this tank. Just the first round of the day, before you start filling, we would check it. Nothing too unusual here. We can set up 2 barrels at the same time with an overflow barrel beside each one. And then when we are full, we'll pull the filler out and just top it off, make sure we've got every bit of air out. We park the back of the drum on a 2x4, food grade 2x4, so that the barrel is tipped toward the bung at the
You get a
high
little
side.
bit more in there, don't you?
You get more in there and get more air out.
Plus, when it shrinks, right? You'll actually get
Vacuum.
yeah.
Yeah. And so then the overflow barrel goes on the filler stand next. You don't continue to use the same overflow barrel continuously through the day because that's going to be full of cold syrup before you finish the day.
Very cool.
So, how hard do you have to suck to get that syrup up out of that cup right there?
I was just noticing that too.
I just wondered. I didn't,
Yeah, and
The one leaning on the food grade 2x4.
I'm sorry. You're going to delete that.
you might want to keep it.
It's fun. It's real.
Yeah, it's
Cool.
real.
What's the story you want to
So
tell?
the first time that I was here and really didn't know Glenn, I met his wife, Ruth. So they had a really big rig over here, had a small 4-foot flue pan, and the rest was finishing. And
Yeah.
she's just working like crazy. And she had that washer over there, and she's just moving and working. And so I told my wife, I have a really good example for you to follow. And I described a little bit about, and I just want to be a blessing for my wife,
Yes.
just to help her, and so she took it pretty well.
Yeah, good.
But Ruth was working like crazy.
Yeah.
Well, Cheryl did chores today.
Yeah, she fed the cows.
Good.
Yeah.
Good.
Yeah. So
Yeah, it's a pretty lazy husband that can't find plenty of work for his wife
exactly.
to do. Yeah.
Exactly.
Yeah.
Those steam. That's probably a game changer.
Oh my goodness. Yeah.
Do you just open the valve and does it just run?
It does. They're auto drives, of course, but
Is there something about 66, 67 bricks that The syrup just knows it's done.
No.
Because some people are just opening them up, and it's like, how are you getting? I mean, the valve's wide open. They're just like, it just goes.
Yeah. Yeah, the auto draw does that if it's tuned in right, of course. But we switch sides on the exit of the pan every hour. We'll niter up the pipes in the pan quickly if we don't switch regularly. And interesting, on these pans, our ROs are producing 30 brix concentrate, which seems really heavy, but on most syrup pans, you're going into that pan higher than 30 brix. You're probably pushing 50 brix going into a syrup pan. And so to have 30 brix coming in, that will redissolve the niter buildup on the steam pipes on the light side while you're drawing on the other side.
I didn't think of that.
And so the middle of the pan takes it the hardest.
Because it's not getting that
Differential.
sap that's got some solvency left.
Yes. Yeah.
How often do you have to wash the
So we wash them every night. Yeah.
automatic washer?
Yeah. Yeah, it is.
And it washes the inside and the outside of the pipe?
It washes the outside of the steam pipes, not the inside.
Okay,
The inside stays clean.
gotcha.
And it washes the surface of the pan, but the surface of the pan isn't cooking the way it would on a normal pan. So we have a pump that we've put together that hooks on to the draw side and the input side. So it's pumping acid water through the pan through the night and cleans it up really nicely. Then we pressure wash the pans before we go back into service again.
You might have said, but what's that tank there?
That's just hot water.
That's the hot, from the,
Yep, we have more heat exchangers. I think we keep Bell and Gossett in business. So the heat exchangers take permeate from our permeate tanks and heating up with the return steam slash condensate going back to the boiler and ensuring that we're completely condensed there and providing hot water for us, plus the preheaters from the
How
hose.
hot does the condensate heat water? Darn near 212?
It'll go
Maybe
past
a little
that.
higher if it's got
it'll
some
go
pressure.
past that if
Okay.
you're not careful. Yeah.
Okay.
Yeah.
Now, how about
Sometimes we boil in those heat exchangers, and that's not a happy place to be.
no?
No.
Now your boiler, the fuel source, is it gas, oil?
Number
Oil.
2 fuel oil.
Okay. And it's just a big. It's not a low pressure. You don't run low pressure steam for something like this.
65 psi. Is
I
what
got
we
you.
do. And in
It's
most
plenty.
applications, that's considered low pressure, but
Gotcha.
the boilers are rated for 150, so we're doing half of what they're intended to do.
So now I get to tell my Glenn stories,
Okay.
where Glenn is often asked to speak at events, and somehow we were able to get him down to Ohio a few times, and I'm probably going back 15, 18 years, and my dad and I are, we just got into tubing, and we're listening to Glenn talk about making a round hole. And we had no idea that that hole had to be perfectly round. And my dad's sitting there next to me, and he says, well, you don't even want to start, put your drill bit on the tree and then start it, because it might get a little turn. And this was novel to my dad and I, because we had a little piece of that wood left in that hole. You gotta ream that thing out. And it's like, I didn't say anything, my dad didn't say anything, but we didn't make oval holes after listening to Glenn. That's story one. Story two is, I will never forget, he sits down in this auditorium and he talks about the word vacuum and it being a strange word and helping us all how to spell it. And it was so subtle, but I've never forgotten to use.
Yes.
And that's how he started his speech. Such a strange word. He was so nice. You dummies from Ohio, let me help you. This is how you spell vacuum. And we needed it. You needed it. And then the third one that I always think about, and I can say it's true, is that maple syrup is the only crop in which the farmer gets the most. And for every dollar that we bring in at Bissell Maple Farm, 65 cents goes to the farmers. And for every dollar that our customers bring in, about 50 cents goes to the farmers. And I can't think of another crop where that's the case. And I remember you saying that, and I'm like, those packers are just getting rich. And now we have this thing called a balance sheet and accounting and stuff.
Oh boy, you don't want that.
I tell you, my number one most important thing is the syrup, and we buy a lot of it, and it's true. For every dollar we bring in, 65 cents goes to farmers. Then we got to buy packaging, health insurance, pay the rent, pay the energy, Fred's hefty salary.
Yes.
It's
Well,
ridiculous.
fixing up your ski doos and all them things.
Well, don't listen to that. But I appreciate it, Glenn. It's been cool. Thank you.
Super.